Hey guys, so today I'm just going to go over the introduction to 4-6 graphs of tangent, cotangent, cosecant, and secant. So honestly, we didn't get too much done today, but we did introduce the idea of what does the tangent graph look like. So let's go ahead and start with that. We wanted to define what is y equals tangent of theta on a graph. So in order to graph this, we went ahead and defined the x-axis as being theta and the y-axis as being tangent. So we are going to be taking a memory quiz over this in the next couple of days, probably next week at some point. So kind of keep that in mind. Biggest thing in order to graph tangent of theta is to remember that tangent is equal to y over x. So we went ahead and created a table to create some points for tangent. First, we went ahead and looked at what happens when theta is equal to 0. Well, when theta is equal to 0, we have an ordered pair on our unit circle of 1, 0. Remember that tangent is y over x. So we're going to say y, which is 0, divided by x, which is 1, which is actually equal to 0 here. After that, we went ahead and plotted that on the graph. So at theta equals 0, tangent is going to be 0. From there, we went ahead and graphed what happens when tangent is at pi over 4. So at pi over 4, we said y over x. At pi over 4, the ordered pair on our unit circle is radical 2 over 2, comma radical 2 over 2. If I divide radical 2 over 2 divided by radical 2 over 2, the same thing divided by the same thing is 1. So at pi over 4, we went up to 1. At pi over 2, we got something interesting. Pi over 2's ordered pair is 0, comma 1. So if I went ahead and tried to find what's y over x for 0, comma 1, we're going to get 1 divided by 0, which is undefined. So what this means in context of the graph is this. We're going to see an asymptote, an undefined value, at pi over 2. So we're going to see an asymptote at pi over 2. We went ahead and found what happens if we evaluate at negative pi over 4. Negative pi over 4 is going to give us a value of negative 1 down here. And negative pi over 2 is going to once again give us an undefined value. So that means at pi over 2 negative, we are once again going to see this asymptote. So the overall tangent function, when we go ahead and graph it, is going to look something like this. There's actually going to be several periods of this. So if we continued the pattern this way, here's what the rest of the tangent function would look like. If we continue the pattern, is we'd see the exact same graph to the left, and we'd see the exact same graph to the right. Oops, that's not the exact same graph. I wonder if I don't know how to clear that. All I know how to do is cover it up in white. Okay. All right. Don't look at that one. There we go. Okay. All right, so what we can see here is that this tangent function, it has a period just like sine and cosine would, but its period is not the same. Its period actually starts over a little quicker than sine and cosine would. Notice how the distance between here and here, which is the repeat zone, is pi over 2 and negative pi over 2, which adds to pi. So we can actually see here that the period of tangent is different than the period of sine and cosine. The period of tangent is pi instead of pi over 2, which is going to have a bunch of implications for how we sketch it going forward. All right, so that's actually all we covered today. We actually did a long session on the proof of why you can't divide by 0, which we'll go ahead and skip in this video. Please message me if you have any questions or concerns, and have an awesome weekend.